This is part of problem 20. Given a right-angled triangle of hypotenuse L, other two sides N, K, right-angled triangle, and the other two angles are O and M. We have the dimensions. N is 12.61 units. O is 53.1 degrees. We have to find K, L, and M. In this video, we're going to use our Trig tools to find the value of K. That's the length of that side there. We start off with we'll try the sine. So if we take the sine of the angle O, which is 53.1, equals the opposite over the hypotenuse. The side that is opposite to the angle O is N, and that measures 12.61 units. The hypotenuse is L. We don't know what L is, so we put it in like this. This is of no use to us because in this instance because we're trying to find K, so we cross that out. Let's try the cosine. So the cosine of the angle O, which is 53.1, is equal to the adjacent, which is K. We don't know what K is, divided by the hypotenuse. We don't know why the hypotenuse is L, so that is of no use to us either because there are two unknowns in it, K and L, and we can't solve that equation if there's two unknowns. Next tool at our disposal is the tan. So the tan of the angle O, which is 53.1, is equal to the opposite, which is N, and N is 12.61 units, divided by the adjacent, which is K. K is an unknown. We put this in here. So the opposite over the adjacent. This will work for us because there is only one unknown. So we can rearrange this equation to find K. We have some other tools. We have the Pythagoras tool, which tells us that the square on the hypotenuse, which is L, is equal to the sum of the square of the other two sides. So the square of the hypotenuse is equal to K squared. We don't know what K is. K squared plus N squared. N squared is 12.61 squared. We can't use this because there are two unknowns, L and K. We can't solve this equation for two unknowns. The last tool we have at our disposal at the moment is that the sum of all the internal angles must add up to 180 degrees. So this angle here is M, that's unknown, so we put it in as M. This angle here, it's a right angled triangle, is 90. So we put that in as 90. And this angle, angle O, we know it is 53.1 degrees. And they must add up to 180 degrees. This is of no use to us because it would be useful to find M, but we're looking for K. So this equation and this tool is of no use to us. So out of all our tools here, the only one we can use as use to us is the tan. So let's try and solve using the tan. We're told now the tan of the angle 53.1, that's the angle O, is equal to the opposite, which is N. We know what N is, it's 12.61, divided by the adjacent, which is K. We don't know what K is, and we're trying to find K. Now we're trying to find K here, but that means getting K eventually on its own on one of the sides. K is a divider here. We don't want it as a divider. We don't want it as the denominator in it, so we want to clear this K out of here. K is a divider. The inverse of a divider is a multiply. This is an equation. If we multiply both sides by K, we'll end up with a K multiplying here, and that K will cancel that K. So let's just do it. So bring the K across and becomes a multiplier. So K multiplied by tan of 53.1 is equal to 12.61. We've got k multiplied by tan 53.1. We want to find k on its own, which means we've got to get rid of this tan 53.1. This is a multiplier here, and the inverse of multiplication is division. So if we divide both sides by tan of 53.1, we'll get rid of it this side and it'll appear on this side. So we have k equals 12.61 divided by tan of 53.1. This looks what we want now. We've got k isolated on one side and we have some figures on this side that we can process. So let's do some calculator work. 12.61. The tan of 53.1 to 4 decimal places is 1.3319. Now I do more calculator work, do the division. K is equal to 9.47 to 2 decimal places. That is our answer for K up here equals 9.47.